Here we have another implicit differentiation example problem. So we want to find y prime by using implicit differentiation. So our example problem, we have cosine of x squared plus 2y plus x e to the y squared, which is going to be equal to 1. So the first step is we want to take the derivative with respect to x of each of our three terms. So when evaluating the derivative for these three terms, we can see that the first term we're going to need to use the chain rule since we have an outside and inside function. For the second term, we're going to need to use the product rule since we have two functions that are multiplied together. And for the last term, we just have a constant, so that'll go to 0. The next step is we can go ahead and start applying our derivative using the chain rule. So we know the derivative of cosine will be negative sine. We'll leave this inside term alone. So that's the second step in our chain rule. So we'll have x squared plus 2y. And then we'll take the derivative of this inside term. And so we'll get 2x plus 2y prime. And like I've said before, this y term is really just y of x. So it's a function of x, which is why we have this y prime term. The next step is we'll need to take the product rule. So we'll have 1 for our f prime position, e to the y squared for our g position, x for our f position, and then 2y e to the y squared, y prime for our g prime position. After that, we want to simplify or combine like terms. So we know that this is just our normal functions, and then these are our functions that have y prime in them, because the goal is to get y prime on the other side, and then ultimately factor out that y prime. So you can see I've moved this term to the right-hand side, and I've moved this term to the right-hand side as well. And then the last step is we want to take this term and factor out the y prime, and then we can go ahead and divide the left-hand side by the right-hand side, and we'll get our solution for y prime, as you can see here.